we were doing intermolecular forces. What all did we cover in intermolecular forces? We did 4. What all did we do?
Iron.
What all did we do? Karan? Intermolecular.
Dipole.
Yes. Dipole interaction. What happens in dipole interactions?
Permanent dipole.
So it happens due to the presence of permanent dipole. That is, first thing, which is a permanent dipole is present in a molecule, permanent dipoles, and these permanent dipoles are present due to the electronegativity difference between the atoms. Difference between the atoms in a molecule. Right? That is what we understood last class. And the example I took was HCl, wherein I can see the dipole formation like this, delta positive, delta negative. This can interact with another HCl molecule, delta positive, delta negative. Right? इधर आ जाओ बेशक, थोड़ा बोर्ड दिखेगा अच्छा से. Remember?
Yes, ma'am.
Dipole interaction is clear. Second type, what we did? What was the second type?
Dipole interaction.
Dipole induced dipole interaction. So what happens in this? Dipole induced dipole interaction, what happens in this? So there will be a presence of one dipole already and one non-polar molecule. So that means interaction between a polar and a non-polar. So what is it happening? The dipole present in the polar molecule is inducing the dipole on the non-polar molecule. What is the example we took in this case? What was the example given by me? Were you present in the last class?
Yes.
Xenon with water. Right? The next type which we discussed in the last class was ion dipole interaction. As the name. So see, from the name itself you can pick it up what is happening. So that means a cation or an anion is interacting with the dipole present molecule. That means a polar molecule. And this type of interaction is referred as pure ion dipole interaction. Example could be NaCl in water. Clear? The fourth type which we did in the last class was which one? What was the fourth one which we did, Karan? Suresh? What was the fourth one which we did? So dipole is done, dipole induced dipole is done, ion dipole is done. So what I am left with? Ion induced dipole interaction. Ion induced dipole interaction. What happens in this? An ion is inducing the dipole in the non-polar molecule. So the example could be iron with oxygen. Oxygen is non-polar in nature. Iron is inducing a dipole, and the interaction between these two is resulting in ion induced dipole interaction. Induced dipole interaction. Clear? So, starting the class, so the fifth type is dispersion forces, or referred by London forces or van der Waal interaction. Yes. So any type. So if you see in a molecule, there is no interaction of dipole or iron or anything, then it will fall under van der Waal forces. So like oxygen molecule, for example. So the interaction between the two oxygen molecules is weak van der Waal forces. They are the weakest among all of them. So if no dipole is present in any of the molecules, oxygen does it has a dipole? No. So if no iron is present, so that means what category am I going to make it fall under? I'm going to make it fall under dispersion forces or London forces, or also known by the name van der Waal forces.
Both are equally electrolytic.
Equally, there is no polarity difference. No polarity difference in the chemical bond. If there is no polarity difference in the chemical bond, that type of interaction will result in van der Waal forces. So mostly these forces are also found in your organic compound. So you might have heard about ethane. There is not a difference in polarity. This reacting with the carbon, this having interaction with the other carbon molecule, and this can proceed as a chain. So it can again interact with another molecule of ethane and the chain propagates. So this type of interaction is referred as van der Waal forces or London forces or dispersion forces. Clear?
Yes, ma'am.
Now, the last type of interaction, that is hydrogen bonding. And it is a special case. Why is it a special case? Hydrogen bonding is only shown by few particular compounds which has nitrogen or a fluorine or a oxygen group present along with the hydrogen. So how it should be present? As NH, FH or OH. If these three bonds are not present, then no hydrogen bonding will be shown by any. Yes. So let's take by example, the famous example I have water, which shows hydrogen bonding. So OH. So how the hydrogen bonding is represented? The oxygen will interact with the hydrogen of the other molecule, and the hydrogen will interact with the oxygen of the other molecule. So this goes, so it will interact with the oxygen, and whereas this will interact with the oxygen. Clear? What about you, Karan? So this chain can go on. So O, H, this O, H, H, O, H, H. This chain can go on. This is how hydrogen bonding is present. Now, if I see about the energy of the hydrogen bonding,
Can they create a loop?
They can. They can. So hydrogen. So why water has high boiling point, and most of the organic compounds, ethane and everything, they are highly volatile in nature. Alcohol and everything, they are highly volatile in nature. In spite of having a little hydrogen bonding in alcohol, they are still volatile in nature. This still tops the list. Why? Because of the presence of the hydrogen bonding. So if I have to explain, the high boiling point of certain molecule in which OH, NH or FH bond is present, then I will explain why a hydrogen bond. Strong interaction in the liquid results in requiring higher energy.
Hydrogen bonds are strong.
Yes, hydrogen bond. So that's what I was coming at. So the bond energy, that is this hydrogen bond energy, is almost 10 to 100 kilojoules per mole. So that is how strong it is.
And is it greater than the OH bonds? Than the original?
No. They are still weaker than that. Obviously, they are still weaker than that. They are. That's why it is being mentioned with the dotted line, not with the single line. So if I tell you to draw the hydrogen bonding in the case of CH3NH2, can you draw it for me, both of you? So you drew the hydrogen bonding CH. Will it represent? So see the previous slide. It interacted with the hydrogen of another hydrogen which is attached to another oxygen. And you did intermolecular. We are talking about intermolecular. You did intramolecular within the molecule. So the molecule was
It's
CH3. So CH3NH, right?
NH2
This is NH2. So the bond is between these two, right? How is the CH3 present in the nature?
It was like CH3 and between.
No. This is one molecule. CH3NH2. That is one molecule. Shivesh, are you able to draw? Shivesh, correct.
Yes, ma'am.
So how did you draw?
It was like this.
So can I write CH3NH2 like this? Still you are doing inter. So I am talking about intermolecular forces. Am I talking about an interaction between these two? This is intramolecular. This is one molecule and this interaction with another molecule. We are discussing that intermolecular interaction. Intermolecular interaction. See it in the previous slide, what is happening.
Okay, wrong word.
So, we did not find the interaction between C and C. We found the interaction of this CH with another molecule.
This.
So, what is happening then? Okay. So, if I say instead of this, I make an interaction like this. Oh, sorry. The nitrogen of this interacting with the hydrogen of this.
Both are not slightly different.
Why it is different? So understand, when I say the condition NH should be present. So had it been CH3 thrice N, will it show hydrogen bonding? There is no H present. So the interaction is between the nitrogen of one with the hydrogen which is bonded to the nitrogen, not with the CH3H. Is it clear?
Yes.
So when I say the presence of NH is necessary for representing hydrogen bonding, what do I mean by that? I mean that the nitrogen will interact with the hydrogen of the corresponding NH bond. present in the adjacent molecule. Now clear?
Yes,
Karan, is it clear?
Yes, ma'am.
Fine. So we studied about all the laws. We saw the ideal gas equation and we did the intermolecular forces. Now what is left in states of matter is kinetic theory of gases. That constitute the rest of the chapter, which is very major.
and we finish the chapter.
Probably by tomorrow. Next we'll start off. Next week we'll start off with thermodynamics anyway.
Yes, sir.
Thermodynamics.
How do we do?
Very good.
Very good.
Very good. So very important as well. So I come to kinetic theory of gases. So in order to explain the kinetic theory of gases, I made a presentation a little so that less effort is. Karan, can you see it?
Yes, ma'am.
Okay. So, first thing, what all do I know about gases? What do I know? They have indefinite shape. I've been studying from class 7. The gases have indefinite shape and indefinite volume. Right? These two things I've been studying since ages. Gases can expand and gases can compress. They occupy how much is the space required, how much is the space available, they go and occupy that space. So that means there is huge spaces between them. So I can expand them, I can compress them as much as I want. Gases have low density as they are so far away present in the and so much of empty space is there. That's why they have low densities as well. Gases diffuse uniformly throughout the container to form a homogeneous mixture. In order to understand that, let's say I have a balloon. Okay, let's say I have a balloon which is connected to a container and there is a stop knob. Fine, there is a container. So when I release this, open this, so the diffusion will occur. The gases present in this balloon will enter the space inside the container. When they are entering, so let's say it has oxygen and hydrogen mixture. It has oxygen and a hydrogen mixture. What would happen? As soon as I remove this stopcock, what would happen? This air will go and fill in. Will it have a preference that the oxygen will occupy above and the hydrogen will occupy below? No. They are distributed uniformly and homogeneously, irrespective. Right? It is true for every gas. And that is the properties of the gas which I have studied so far.
What was already in the container?
Nothing.
So vacuum.
It was an empty container.
Vacuum.
You can say vacuum, definitely. Fine. So, when I remove this top knob, what happened? The air present inside the balloon orified into, that means diffusion occurred and it filled in the spaces between that, in that container and fill in it with uniformly. Right? Clear? I will have to do this. Atmospheric pressure. Now arrives another term that is associated with gaseous molecule. What is it? So that is the gas pressure. So whenever a gas is present inside a container, it's going to exert certain pressure onto the walls of the container. That is the pressure of the gas, right? And there is something referred as atmospheric pressure, which is generally for here, it is 1 atmospheric pressure, that is what it is stated. So atmosphere also exerts certain pressure, that is equal to 1 atmospheric pressure. If I try to understand, gas pressure results of a constantly moving molecule. So the particles which are present are colliding with each other, they are moving in all direction, and they are striking with each other. Now what would happen at high pressure and low pressure? The number of collision, what do you expect? Would be high or low in the higher pressure and lower pressure? What do you expect?
Higher pressure.
At higher pressure, the number of collision will be high. Energy of the molecule will also be high. In the lower pressure, what would happen? Both the cases, the number of collision will be less as the particle is moving with the less speed. Right? This is what is happening. So if I proceed further, so what are the variables which are actually contributing to the gas pressure? What are the increase or decrease of the volume? So if I take the smaller container, if I take a bigger container, right? The volume of the container will affect the gas pressure, first thing. Second thing, increase or decreasing the temperature of the gas. So let's say I have a gas at 40 degrees Celsius in the same volume, and if I have a gas at 100 degrees Celsius in the same volume. So then also the gas pressure will be, and increase in the number of molecules in the container. That will also be affect when more number of molecules are present in the same container, will affect the the pressure of the gas.
We can state this by using the laws.
We can state this. That is what I am coming at. So that is what the ideal gas law was. PV is equal to nRT. Right? That is what we derived so far. That PV is equal to nRT. Karan, are you following?
Yes, ma'am.
Fine. So these are the variables it depends upon. The next thing which we did was the Dalton's law. If you remember, in the Dalton's law, we said that individual pressure of each of the gas present in that particular system will be equal to the total pressure. So if I think about the atmosphere has oxygen, nitrogen, argon, water, carbon dioxide. This is the composition of an air. So when this is the composition of air, so when I see the total pressure, that pressure, the total pressure is sum of the individual pressure of each of the gas present in that composition. That is what my Dalton law said it, and that is how I defined the Dalton law. And when I saw the expression mathematically as well, what happened was the total pressure was equal to P1, P2, P3, and whatsoever how many it is present. And what else the equation I said it? I said, this is coming as blur, but I'll write it. The chi, that is of a particular mole fraction of a particular compound is equal to the pressure, that is pressure, and this will be total pressure. So if I want to find the individual pressure of every gas present in that, I would have to multiply the mole fraction into the total pressure. This formula is very important because you get many questions based on this. What type of questions does actually arise in this? So let's try solving this question. So the question is given, the vapor pressure of the water in air at 28 degrees Celsius is 28.3 torr. We calculate the mole fraction of water in a sample of air at same 28 degrees Celsius and 1.03 atmospheric pressure. 760. 1 atmospheric pressure is equal to 760 torr. Karan, can you see the question as well?
Yes, ma'am.
Please solve it and tell me what is the answer. How will you solve it? It's a very straightforward question.
Now we have to find the mole fraction of water
Yes,
in a sample of air.
in the sample of air. Exactly.
Ma'am, so PT is 1.03 atmospheric pressure.
PT is given, okay. So the PT is given as 1.03 ATM. Right?
And mole fraction we have to find.
Okay.
And ma'am, we have
Mole fraction of water need to be reduced.
And ma'am, the pressure of water is given as 28.3 torr. So
Yes. So the pressure of water is given as 28.3 torr.
Ma'am, we converted and ma'am,
Karo, calculation karo. Karan, did you understood how do we do it? What is the formula to be used? What is the formula to be used, Karan?
dB is equals to nRT.
No. Chi of water
Ma'am, we have to.
is equal to
Can we
pressure.
convert atmospheric pressure into?
Yes, any way, whichever is comfortable to you. This is the formula which we are going to use over here. And 1 atm is equal to 760 torr. How much does it comes out to be? करंट कितना आया? आंसर कितना आया आंसर?
Ma'am, 26.8.
काई मोल फ्रैक्शन कभी 1 से 1 से ऊपर हो सकता है? Can it ever be above 1?
0.1.
दोबारा करो, कैलकुलेशन चेक करो.
28.3.2 to 2 hour.
So
Ma'am, 0.03.
yes, 0.036. That is the answer. Check your calculation again. So the answer is supposed to be 0.036. क्या गड़बड़ करी है देखो कैलकुलेशन में आपने. जब आपने इसे कन्वर्ट किया फिर
Yes,
इसे एटीएम को कन्वर्ट किया कितना आया?
2.82.
कैसे आ सकता है 222? यहीं पे गड़बड़ है आपकी कैलकुलेशन में. ये तो हो ही नहीं सकता. करण आपने कैलकुलेटर यूज किया खुद किया है?
मैंने खुद ही किया, सिर्फ पॉइंट हटा के किया.
अच्छा चलो गुड. क्या आया फिर? ये कैलकुलेशन एरर से तो मैं भी नहीं बचा सकती. क्वेश्चन आते हुए गलत होगा फिर. पता चले एक ऑप्शन था 0.12 मार्क करके आ गए. फिर
782.
देखो ना मिस्टेक तो वैसे ही पकड़ी जा सकती है. अगर 1 एटमॉस्फेयर
Yes, ma'am.
760 है तो
उससे
1.03 कैसे आपका 222 हो सकता है? So 782, so that means 28.3 divided by 782, right? That is what you have to do. That comes out to be
Yes, on the bar 0.026.
clear. This was one of the simplest questions. Okay, let's do this. This is a very interesting question. A gaseous mixture made from 6 gram of O2, 9 gram of methane and is placed in a 15-liter vessel at 0 degrees Celsius. So what all information is given to me? It's given 6 gram of O2. That means oxygen mass is given. Similarly, 9 grams of methane, mass of methane is also given, and the volume of the container is given, and the temperature is also given. What is the partial pressure of each gas? And what is the total pressure inside the vessel? So, quickly करो भाई, ये लेजीनेस नहीं चाहिए मुझे. करण समझ आया कैसे करना है? इधर PV is equal to nRT फॉर्मूला यूज होगा.
Yes ma'am.
तो सबसे पहला काम होगा नंबर ऑफ मोल्स निकालना, राइट? फर्स्ट thing which I have to do is to calculate number of moles of oxygen and methane. What will be the number of moles of oxygen and methane? क्या है number of moles?
Ma'am, 3/16 और 9/16.
क्या? अच्छा तुमने काट दिया, ओके. 6/32, राइट? उसी को तुमने बोला 3/16. मैंने बोला क्या बोल रहे हो? 9/16 कितना आया? कैलकुलेट कर दो. ये तो छोटी कैलकुलेशन है. क्या आया करण? नंबर ऑफ मोल्स कितने आए? दिस इज माय O2 and this is my CH4.
3/4. 3/4.
वैल्यू पॉइंट डेसिमल्स में बताओ.
1.3.
करण क्या आया इसका वैल्यू?
1.3.
Ma'am 1.7.
नहीं, पॉइंट में से होगा.
1 पॉइंट कैसे होगा?
नहीं, 0 पॉइंट.
1 पॉइंट कैसे हो सकता है?
Yes,
6
ma'am.
तो छोटा है 32 से और 9 भी छोटा है
Yes,
16
ma'am.
से.
0 पॉइंट.
मैम उसका 6/32 का पूछ रहे हो?
दोनों का पूछ रही हूँ, एक एक का बताओ.
0.75.
इसका
हम मिला के.
मिला के 0.75 है.
हाँ.
क्लियर?
हाँ.
इंडिविजुअली
इंडिविजुअली क्या करना? पहले उनको ऐड कर दिया फ्रैक्शन में.
चलो ठीक है, कर दिया. ओके फाइन. तो आपने टोटल नंबर ऑफ मोल्स निकाल लिए. यू आर टेलिंग मी दिस.
यस मैम.
मोल फ्रैक्शन निकालने के लिए आपको इंडिविजुअल नहीं चाहिए होंगे, आप बोलना चाह रहे हो मुझे?
हाँ, मोल फ्रैक्शन.
पार्शियल प्रेशर ऑफ ईच गैस, ये भी चाहिए ना मुझे.
हम पहले वो पीवीआरटी से प्रेशर निकालो.
टोटल प्रेशर निकालो. चलो
तो पी पता नहीं है इनटू 15 इनटू इक्वल्स टू एन की वैल्यू 0.75 इनटू 0.0821 इनटू टेंपरेचर 273. P equals to 0.75. चलो ये कट जाएगा 15 से. 1
करंट क्या आया? PV is equal to nRT में प्रेशर टोटल is equal to nRT upon V. N is 0.75. Rest of the values are given on the question. What does PT comes out to be?
मैम 0.05.
नहीं, wrong है. क्या क्या वैल्यू पुट करी? n किया 0.75 इनटू r किया 0.0821 इनटू 273 अपॉन 50.
बहुत ज़्यादा प्रेशर आ रहा है.
कितना आ रहा है?
मैम 112096.5.
1 पॉइंट
मैम 112096.5.
रॉन्ग है.
अच्छा, इसको अपॉन
कहीं पे डेसिमल की मिस्टेक हुई है. देन क्या आया आंसर इसका?
1.12096.
Yes. So the total pressure comes out to be 1.1. What will be the unit?
सबको हमने बेसिक में लिया तो एटमॉस्फेरिक प्रेशर
ATM.
अब मोल फ्रैक्शन के लिए उसको करना पड़ेगा
Yes.
तो
आया तुम्हारा आंसर करण?
Yes, ma'am.
Yes मैम बोल रहे हो, कैलकुलेट किया है?
मैम कर लिया.
6/32 कितना आ रहा है?
6/32.
हाँ, यहाँ पे वैल्यू क्या आएगी?
मुझे 5.33 है.
5.33 तो ऑलरेडी गलत आंसर है, ये देखो कैसे आ सकता है? 6 छोटा है नंबर, तो पॉइंट समथिंग आना चाहिए आंसर. मैं कैलकुलेशन बताऊं तुम्हें कैसे करते हैं? 6 है, 32 है, 60 यानी कि पॉइंट 32 टाइम्स जाएगा 1, कितना बचा? 8,
Yes, ma'am.
28, 280, 320 होता है. अगर मैं 10 टाइम्स कर दूं तो 320, so that means 8 टाइम्स जाएगा ये.
Yes, ma'am. 0.1.
अब ये मैं नहीं सिखा सकती, ये आपको ये तो आपको करना आना चाहिए. 9/16 is
0.56.
0.56. अब individual partial pressure comes out to be, what will be the formula?
1.12 mole fraction.
So partial pressure of oxygen is equal to chi of oxygen into total pressure. So 0.1875 divided by 0.75 into 1.12 atm. So whatever the value comes, that is your answer for the pressure of oxygen. Similarly, pressure of methane would be chi of methane into Pt, which is 0.56 upon 0.75 into Pt क्या है? 1.12.
Then
कोई नहीं, घर पे कर लेना कैलकुलेशन. वैसे आंसर क्या आएगा मैं बता देती हूँ आपको. 0.28 and this is 0.84. Clear? And this is the most commonly asked question.
total pressure तक कर लिया.
ठीक है. Now we come to another phenomena in which aqueous tension. There is a term which is referred as aqueous tension. So in order to understand aqueous tension, this is the setup for an experiment. So let's say metals react with acid to liberate hydrogen gas. Right? Yes. पढ़ा था? So that means metal with an acid results in release of salt plus acid. Sorry, salt plus hydrogen. Hydrogen gas is evolved. Now, so let's say I have this tube like a structure stating that I have my metal and acid inside it and it is sealed. And the pipe which is going through it, and this is water. This is your water. So the hydrogen gas which will be released, it will be collected over here. So whatever the amount of hydrogen gas is formed. So whatever the amount of hydrogen gas will be formed, it will be collected over here. So that pressure of hydrogen gas liberated or any gas, this is one particular example I took, so I am saying hydrogen gas. But instead, if any of the experiment oxygen gas is liberated or CO2 gas is liberated, then that gas can be collected over water and the pressure can be determined. So that pressure will be the P total, because that air, that gas will be moist in nature due to the presence of water. So if I have to calculate the pressure of that gas particularly, then if I subtract, so this P total consists of P pressure of that gas which is liberated plus the aqueous tension. This is referred as aqueous tension, that is pressure of the water at that particular temperature. So let's say this.
Now we are talking about pressure exerted on whatever is inside on the container.
Yes, on the container. So what is happening? So in this experiment, what happens is whatever the gas collected over it will be exerting pressure onto the container or on the walls of it. So that is denoted by the total pressure. But this gas is generally moist in nature due to the presence of water. So that is how pressure of the gas plus the aqueous tension will give me the total pressure. So if I have to calculate the pressure of the gas, then I would have to subtract my P total from the aqueous tension. And for a particular temperature, the aqueous tension will be given to you. If this experiment was carried out at 23 degrees Celsius, if the water temperature was 23, the aqueous tension of water for that particular temperature will be given to you. Okay? So this experiment is very helpful in determining how it is helpful. So if at all I know how much of hydrogen gas is liberated over here, so I can calculate how much of metal was present to react it, because I will know the balanced chemical equation. If I know the amount, so pressure of the hydrogen if I know it, I can calculate volume and number of moles by PV is equal to nRT with all the parameters given to me. With all the parameters given to me, I would be able to calculate number of moles of the gas liberated from it. When the number of moles of hydrogen gas liberated is known, by using stoichiometry, I can know how much metal was present, which was reacting with acid, because I will be knowing the balanced chemical equation. Right? So these ways the question arises in this.
We will give in the most extreme thing.
Yes, and we will be asked to back. So either sometime only the number of moles of gas you have to mention. So number of moles of gas, pressure will be the first thing you will be calculating. After calculating pressure, you will be heading back to calculate the number of moles. So let's see how the question arises in this case. So this is the question given to me. So let's see what all is. 193 ml of oxygen. So my volume is already given. Was collected over water. That means it is collected over water. On a day when the atmospheric pressure was 762 mmHg. The temperature of the water was 23 degrees Celsius. So temperature of the water is given. Why is it important? Because I need to find out the vapor pressure, the aqueous tension at 23 degrees. That is why this 23 degrees is important. How many grams of oxygen were collected? How many grams you need to? Volume is given to me. Pressure is given to me, P total. The pressure, mmHg. So they have given the same values in the same, these two are in the same, mmHg. And 1 atmosphere is equal to 760 mmHg, barometer reading. 760
equals to
torr. 760 torr. Okay? So, why am I not making you write? Because as you solve the question, this will be by hearted in your mind. If I make you write, you will be always like checking over there. Instead, if I tell you 1 atmospheric pressure is equal to 760 torr, which is solved just now. Similarly, I am telling you 1 atmospheric pressure is 760 mmHg. Clear? So what is happening? These all information is given to me. Now, how will I proceed? What will be my first step?
We have to calculate the grams of oxygen.
Yes. So for that, what will be my first step? First thing would be to calculate the pressure of the gas. Total pressure minus this will give me pressure of the gas.
Yes, on pressure of gas.
What is the pressure of the gas? First thing. Karan, are you following?
P total, which is 760.
Yes, ma'am.
minus 221.1.
So how much does it comes out to be?
740.9.
740.9. I would have to convert this into atmospheric pressure. So 1 atm is equal to 760. So X would be equal to 740, right? 42, right? You said.
740.9 upon 760.
So pressure, I got it. Volume is given 193 ml. So that means 0.193 liter. And what else is given? Temperature is given 23 degrees. That means plus 273. It becomes 296 Kelvin. Right? So P, V, T. You already know it. So number of moles you can calculate as PV upon RT. So once you know the number of moles, what would happen? Kindly calculate. Otherwise you won't do it, I know that. After going back home, you won't even turn back. Shivesh, what is the answer for this? Number of moles? Pressure कितना था? Atmosphere में convert करके कितना आया?
740.9 upon 760.
Okay, 760 ATM. Fine? Now do it.
Can I say 740?
So it would be point something.
Yes, ma'am.
0.8 something around it would be 0.8 or 0.9 it would be almost 7400, right? So
Ma'am,
0.8 it would be around.
Ma'am, are there options, ma'am, so that I can convert it and get nearest answer?
So you have to anyways find the number of oxygen,
No, ma'am, but
number of grams of oxygen, number of moles. After calculating that, you have to multiply again by 32 in order to get it. Okay, fine. Do the tedious calculations at home. Please don't forget it. So this is how the answer will look like.
We'll tell you the answer tomorrow.
This is how the answer will look like. 0.975 atmospheric pressure you are getting.
Yes, ma'am.
Yes, ma'am. Oh. And number of moles will be 7.69 into 10 raised to power minus 4 mole. Yeah, बिल्कुल सही कह रहे हो. And into 32 will give me grams of oxygen. So these type of questions arise. Dalton's law as well as.
Ma'am, what's like a quick way to solve tedious calculations like this?
Round it off. When you have 4 options, yes, round it off. But when you do not have 4 options,
what if the 4 options are very close to each other?
then you would have to do the real calculation. Round off works only, I told you, round off will work only when the options are far apart. Round off will only work when the options are far apart. Karan, are you clear? So now we come to our topic, kinetic theory of gases. Very important. Why is this kinetic theory so important? Why is it? Because when a gas is present in a container, what it's going to do? It's going to be in a continuous motion. It's never in a stationary state at all. First thing I know. So it is in a continuous motion. What is the second thing I know? They colloid with one another as well as with the walls of the container. So they are going to be colloiding and they will be colloiding with the walls of the containers as well. So that is what is happening. They colloid with each other as well as the walls of the container. What else? That will result in change in speed and redistribution of energy. So when they colloid, one will gain the energy, other will lose the energy. The law of energy can neither be created nor destroyed. It is always constant. It's only transformed from one form to. So one gains it by increasing its velocity, one loses its velocity, right? Kinetic energy. So the speed and the energy of the molecule are not same at any instant. So what am I trying to say? Every molecule, if I'm going to pick one molecule, let's say this is my molecule A, this is my molecule B, both the speeds will be different. Velocities and the speeds are different. So how do I compute it? How do I say what is the kinetic energy of that particular gas is? So for that matter, I have certain postulates, certain assumptions which I am going to make in order to arrive at that kinetic energy. What are those assumptions? Let's see. Gases consist of tiny particles, atoms or molecules. We consider the gases, they are so tiny in nature. Let it be atoms or molecules. So if I am taking CO2, bigger molecule like that, or irrespective if I take a helium atom. So both the things, they are considered as tiny particles only. Karan, are you following?
Yes, ma'am.
Fine. What is the next thing which I know? These particles are so small compared to distance. So in a container, I know gases will occupy all the space available to him. So when they are occupying, they are so far apart from each other, the distance between them. So the distance between them results in the volume of the individual particle can be assumed to be negligible or zero. So the volume of that particular particle is assumed to be zero. Clear? Third postulate, the particles are in constant random motion. We discussed it just now. They are always in the motion and all those motions are in straight lines.
Who gave these postulates?
Kinetic theory, Maxwell and Boltzmann. Okay? Kinetic theory of gases, these two scientists gave it. Okay? So, what happens? These particles are always in random motion. Random motions means they are colliding with the walls of the container as well as colliding with each other. So the collision with the wall caused the pressure exerted by the gas. That is what we studied so far. The pressure exerted by the gas onto the container is the pressure of the gas. The particles are assumed not to attract or repel each other. So what are we assuming? There is no particular interaction which is present between the molecules.
Just assume.
These are postulates, yes, assumptions made in order to formulate a theory. In order to formulate a theory, these are the assumptions made. What average kinetic energy of the gas is directly proportional to the Kelvin temperature of the gas. So the temperature will determine what will be the average kinetic energy. Higher is the temperature, higher is the kinetic energy. Average kinetic energy.
Why is it saying Kelvin?
Kelvin temperature because the calculations, you have seen it. Whatever the calculation you do it in the Kelvin scale only, not in the degree Celsius or not in a degree Fahrenheit, right? So that is why he specifically. So see, these are the postulate or assumption you can say. So when he made these assumptions, so what were the evidences for these postulates? He must have derived it from somewhere. So the first thing, tiny, it came from that the compressibility. So I know I can compress a gas. If it is occupied, let's say, this was the space occupied by the gas, and if I am going to exert the pressure, I can compress the gas. I can make it reach to this volume. So the compressibility of the gas led to the fact that it is very tiny because there are a lot of empty spaces between them. First thing. Second postulate, there is no attractive forces between the molecules. That gases do not clump. So that means they do not have any type of interaction between them. That is what we are trying to say. Gases mix rapidly. We saw the diffusion process. As soon as the stopcock was removed, it went and filled in all the spaces between them. You want to wash your face? You're feeling sleepy. The molecules colloid classically with the containers of the wall and one another. So the pressure exerted does not diminish over time. So the pressure is always constant. Every time you will observe there is a pressure. Average kinetic energy of the molecule is proportional. Charles' law. Charles' law states that, what is the Charles' law?
Pressure is directly proportional to volume. Pressure is inversely proportional to volume.
volume is
That
directly
is
proportional to
Boyle's
temperature.
law. Charles' law is what, Karan?
Volume is directly proportional to temperature.
Yes. So it is directly proportional. सबसे पहले बॉयल्स किया था हमने, तभी नहीं बॉयल्स ऐसे याद करोगे तो हो गया काम।
ऐसे याद वो मैं नाम इसके से याद करूँ, मतलब ये तो याद है जो पहले करा था उसमें पहले प्रेशर और वॉल्यूम का रिलेशन था, अब पहला बॉयल था, ये
याद करना पड़ेगा वरना ऑर्डर में याद करो B C, B comes before C, ठीक है? You have to make your own methodology in order to understand. Yes. So, अब now the kinetic theory assumptions बने। assumptions बनने के बाद assumptions क्यों बने? These are assumptions for ideal gas particles. Ideal gas. So we studied ideal gas equation PV is equal to nRT, and that is where it is applicable. It is only applicable to ideal gas particles. They are assumed to be small. They are assumed to have constant and straight line motion. They are assumed that the collision is elastic and which where no energy is lost. The only transfer of energy is happening, but no energy. Have no attractive or repulsive forces. Have average kinetic energy proportional to the absolute temperature of the gas. That is what the postulate. So if I try to proceed further, if I try to define the difference between the elastic collision and non-elastic collision, what would happen? What do you expect? What do you mean by the term elastic? The collisions are elastic.
like collisions are
Elastic. When I am saying collisions are elastic, what does that mean? Nah, not flexible.
Elasticity somehow. Okay.
So let's say two molecules are there. 1, 2. They are colloiding. Both have different velocity, V1, V2. Colloiding, boom. After that, what would happen? One will gain energy, move farther away. One will repel, equal and opposite reaction. Right? That is what. So in this process which is happening, elastic means that the जितना एनर्जी एक ने लूज किया उतना एनर्जी एक ने गेन किया, तो जितनी वेलोसिटी एक की लूज हुई उतनी वेलोसिटी दूसरे ने गेन करी.
So how is this elastic?
The perfect system. चलो एक इमेजिन करो सिचुएशन, 2 cars colliding, नेचुरल रियल एग्जांपल, ठीक है? 1 car 1 car 2 कोलॉइड हुआ, दोनों की एक रिस्पेक्टिव स्पीड. कोलॉइड होने पे दोनों एक दूसरे से भिड़ेंगे, पीछे नहीं जाएंगे. क्या होता है इन परफेक्ट वर्ड, क्या होता है इन इलास्टिक? एकदम से कोलॉइड करने पे इम्पैक्ट होगा, रिबाउंस नहीं करेंगे, और रिबाउंस होगा भी तो वैसा नहीं होगा कि एक ने जितनी एनर्जी लॉस करी एक ने इतनी. जैसे सपोज करो एक ट्रक ने एक गाड़ी को मारा, तो ट्रक ने जितनी तेजी से मारा उतना ही माना उसने एक्सेलरेशन गेन करेगा और वो पीछे की तरफ जाएगा, पर इतना नहीं जाएगा कि जितना तेज की ये मार रहा है. ट्रक नहीं, कार, ट्रक एंड अ कार. आई एम टॉकिंग अबाउट, अब मैं रियल लाइफ सिचुएशन अगर ले रही हूँ तो रियल लाइफ सिचुएशन के रियल लाइफ एग्जांपल. तो अगर हेड ऑन कोलिजन हो रहा है, किसी केस में भी हेड ऑन कोलिजन होगा, तो मैं ये नहीं कह रही कि टोटल ट्रांसफर ऑफ एनर्जी होगा, कुछ अमाउंट लॉस हो जाएगा यूनिवर्स में.
यहाँ पर हम एनर्जी से वेलोसिटी ले रहे हैं,
वेलोसिटी कंसीडर कर रहे हैं, तो हम ये बोल रहे हैं कि एक का लॉस दूसरे का गेन है. तो अगर इलास्टिक सिचुएशन समझे, तुम्हारे वॉलेट में 200 रुपए हैं, यू लॉस्ट योर वॉलेट, जिसको मिला उसका 200 रुपए गेन, तुम्हारा 200 रुपए लॉस. इलास्टिक सिचुएशन.
अच्छा मैम, जैसे मैम इसका एग्जांपल है कि 2 बॉल्स कोलाइड कर रही हैं, वो दोनों रिबाउंस हो रही, अब ऑपोजिट डायरेक्शन में जा रही है, तो वो इलास्टिक हुआ, पर नेचर में इलास्टिक नहीं होता है. दैट इज व्हाट आई एम ट्राइंग टू से. आइडियल सिचुएशन डजंट हैपन इन नेचर. दैट्स व्हाई द कांसेप्ट ऑफ रियल गैस कम्स इनटू द पिक्चर. क्यों नहीं, ये हुआ ना इलास्टिक हो,
पर जितनी लेट्स से 5 मीटर पर सेकंड से एक आ रहा था, एक 3 मीटर पर सेकंड से आ रहा, 5 ने टक्कर मारी 3 मीटर वाले।
मैम वो इनइलास्टिक का हो गया एग्जांपल।
तो मैं बोल रही हूँ 5 ने अगर 1 मीटर पर सेकंड अगर लूज किया अपना, 1 मीटर पर सेकंड अगर उसने अपना लूज किया, तो इसने 4 मीटर पर सेकंड, ये भी 4 मीटर पर सेकंड होना चाहिए, पर इन रियलिटी ऐसा नहीं होता है। मैं ये समझा रही हूँ, इलास्टिक केस में ऐसे ही होगा, एक ने 4 एक ने 4, 5 3 था, 4 4 हो गया और अपने अपने डायरेक्शन में चले गए।
मतलब दो एक डिफरेंट वेलोसिटी से कोलाइड कर रहे हैं और फिर बाद में सेम वेलोसिटी से,
ये सेम हो गया ना, मैंने एक 6 3 ठीक है 1, तो एक ने 1 वेलोसिटी 1 मीटर पर सेकंड यूज करी, तो ये 4 बन गया और ये वाला 5 बन गया, ठीक है। ये आइडियल सिचुएशन है। इनइलास्टिक में क्या होगा, इसने 1 लूज किया पर इसने 0.8 ही गेन किया, इसने 1 लूज किया 5 मीटर पर सेकंड से अब ये जा रहा है, पर इसने 3.8 से ही जा रहा है, 4 से नहीं जा रहा है। इनइलास्टिक समझ आया नहीं आया?
yes,
आ गया। कारण तुम्हारा क्या स्टेटस है? So this is what is happening.
Yes, ma'am.
Elastic में collision हुआ. After the collision also the movement remained. Movement remained the same. ठीक है? कोई नहीं, इतना अगर लोड मत दो, अगर इलास्टिक सिचुएशन नहीं समझ आ रहा है, इट्स नॉट दैट कि बस ये याद रखो काइनेटिक थ्योरी उसने क्या बोला था, कोलिजन्स आर इलास्टिक इन नेचर, इतना याद रख सकते हो, ठीक है। सो रिकैप करें, काइनेटिक मॉलिक्यूलर थ्योरी, हैव नो वॉल्यूम, नेग्लिजिबल वॉल्यूम और जीरो वॉल्यूम, हैव इलास्टिक कोलिजन, आर इन कांस्टेंट रैंडम स्ट्रेट लाइन मोशन, राइट, डोंट अट्रैक्ट और रिपेल ईच अदर, have an average kinetic energy directly related to Kelvin. So these are the points. Breakdown postulates, बड़े-बड़े terminology. अगर मैं breakdown करूँ, तो these are the 5 postulates, right? Based on this, he plotted. What did he plot? He plotted the distribution of molecules, Maxwell-Boltzmann distribution. It is referred as. He distributed the fraction of particles versus the speed. So what did he saw? So maximum number of molecules present in a gas found to be under this hump. As I know, every molecule in that particular compound will be of a different speed, right? And then he plotted the fraction of molecule having different speed. So he got a hump like this. So
it's basically saying number of particles is this particular.
Yeah. So if I plot it at this particular speed, these many fraction of molecules are present. At this particular speed, these many fraction of molecules are present. At this particular speed, these many fraction of molecules are present. And you can see at higher speed, less molecules are there. And the maximum fractions remain in the middle region. As I increase the speed, what do I see? There is a decline in number of fractions. This is referred as Maxwell-Boltzmann distribution of molecules. And this distribution is very important. Okay, so what did he do? He plotted the fraction of particle against the speed. Now, let's imagine another thing with this. So there comes 3 different types of velocity which are going to be introduced. MP means most probable. So that is the most probable speed of finding a molecule. So that is the maximum hump. Just close to that is the average speed. This is the average and this is the root mean square. Clear? So what did this distribution give us? Velocity, the speed, RMS speed.
What's that?
We'll come to that. So 3 different types of speed were deduced. In this, the maximum hump gave the most probable speed of that particular molecule. So let's say kinetic energy. I know it is denoted by half mv square right? And right now we are talking about average kinetic energy. Average kinetic energy. So that means kinetic energy average would be equal to half U average square. That is the mean.
We are considering the masses. We are considering the mass is equal for.
Yeah, gas, one particular gas we have plotted for one particular gas, right? So if I see the U average, if I see the U average, it will be U1 plus U2 plus U3 going till UN, right? Upon N, right? And if I see, so if I have to see U average square, then what it would be? U average square amount. I cannot simply modify this. Can I simply modify this? So you imagine this will be square of this completely. So by doing A plus B the whole square, you get A square plus B square plus 2AB. So how many terms am I going to? Then when you have 3 terms, then you have 9 terms. And if I have n terms, how many terms am I going to have?
Considering we are knowing the number of values.
Yes. So that is why.
We'll first add them and then square.
Yes, that is how. We are not going to do the square of it right away here. Clear? So far, no doubt. Now let's see what will happen if I increase the temperature. So these are the two humps where T1 and T2. You can see T2 is a higher temperature. On increasing the temperature, the average kinetic energy. So what do you see? How is the change? So this is my average kinetic energy at T1 temperature and this is my average kinetic energy at T2 temperature. What do I see? The hump has become broader. So what has happened? The most probable speed, which was here, UMP.
The
speed has increased. The most probable speed has increased. The distribution broadens.
Has decreased.
No, speed is here, right? Speed is here. So this speed increases in this way, right?
Yes.
Speed increases in this way. The most probable speed increases. Similarly, the distribution broadens. So that means what I am trying to say, the distribution of molecule. You can see now it's a broader hump. So more molecules are having higher speed in comparison to here. Now more number of molecules are having higher speed. So why is it happening? On increasing the temperature, randomness increases. The number of collision will increase. Number of collision is increasing. That is why these 3 parameters, these 3 things happens. So that means most probable is increasing. That means that will also increase. The average will also increase, and RMS will also increase. So if at all you get a question, what happens to average speed of a gas if the temperature is increased by 10 degree? Decreases, increases, remains the same, or doubles? You have all these options. What happens to the average speed when the temperature of the gas is increased by 10 degree? By 10 degree, I'm just saying arbitrary, by 10 degree. What would happen to the average speed? Decrease, increase, remains the same, or none of these? Increases. So you will get questions like this in the kinetic theory of molecule.
But the number of molecules in the most probable will decrease.
Number of molecule will decrease. Understanding it that way, you cannot quantify this. Why you can't quantify this? Just imagine. Volume of this particular area will give me the number of molecules possessing that speed.
Let's say like in T1 there are X number of molecules with UMP.
Okay.
So ma'am, when we increase the temperature, some of those molecules have decreased speed.
Increased speed. Speed is increasing in this direction. Do not forget that. So many lines over here in order to make you understand. Understand it in this way. UMP is here, and if I see it over here, the speed would be somewhere, let's say 5, 10, 15, 20 kilometer per second or meter per second for that matter. If this is my speed. So UMP for the red graph is 5. And UMP for the blue graph is 10, which is higher, 10 or 5. Still have a doubt? What is your question? Say that again. Maybe I am understanding it wrong.
No,
You got the. Karan, what about you?
मैं क्वेश्चन रिपीट कर
क्वेश्चन ये है कि समझ आया कि नहीं कि जब टेम्परेचर इंक्रीज कर रहे हैं तो मेरा मोस्ट प्रोबेबल स्पीड इंक्रीज हो रहा है, मैं ये कह रही हूँ. इज इट अ राइट थिंग टू से और
हर एक मॉलिक्यूल मतलब उससे ये कह सकते हैं कि हर एक मॉलिक्यूल की उतनी सेम उससे इंक्रीज नहीं होती है स्पीड, क्योंकि वहाँ अगर नंबर ऑफ मॉलिक्यूल्स अगर एक प्रोपोर्शनेट उससे इंक्रीज होती है तो फिर हमका वो हाइट तो सेम रहता ना, मतलब कुछ मॉलिक्यूल्स की स्पीड कम इंक्रीज हो रही है लेकिन हो रही है
नहीं. इसका कहना ये है कि अगर मेरे पास मोस्ट प्रोबेबल स्पीड 5 थी पहले और उसमें मैक्सिमम नंबर ऑफ मॉलिक्यूल्स फॉल कर रहे थे, और जब मैंने टेम्परेचर बढ़ाया तो और लोगों ने स्पीड बढ़ाई अपनी जब स्पीड बढ़ाई लोगों ने, जब स्पीड बढ़ी सबकी, तो मेरा मोस्ट प्रोबेबल मतलब मेरा जो मोस्ट प्रोबेबल मॉलिक्यूल है, जो मैं अगर लेट्स से मेरे पूरे पूल में से मैं अगर उस प्रोबेबल स्पीड को पकड़ने की प्रोबेबिलिटी ज़्यादा बढ़ गई उस हायर स्पीड की. व्हाट आई एम ट्राइंग टू से इज दैट दिस हम रिप्रेजेंट दैट this fraction of molecule has shifted to a higher speed graph. More molecules have gathered higher speed. Here, see, less. So this was the highest speed. This was the highest speed. So you can see the volume which is here, and you can see the volume over here, which will be total of this. So the number of molecule possessing the higher speed is high.
Yes,
Number of particles having higher speed is high. This is what the thing. Most probable speed increases. First thing. Most probable speed increases. Distribution broadens. So पहले distribution narrow था. अब क्या हो रहा है? फैला हुआ है. So broaden हो रहा है. Number of molecule moving with higher speed increases. So more number of molecules are trying to come to the farther side of the graph. यहाँ पे क्या था? बिल्कुल स्टार्टिंग में ही रह रहे थे. अब क्या है? फादर मूव कर रहे हैं जिससे कि उनके पास ज्यादा काइनेटिक एनर्जी है. मैं क्या कहना चाह रही हूँ, उनके पास अब ज्यादा काइनेटिक एनर्जी है. क्लियर है? So this is your kinetic theory of gases. If this is clear, then now we will introduce real gas equations. No. So in perfect world, none of the gas follow the ideal gas equation. Because we have made so many assumptions. What were the assumptions? Volume is negligible, the collisions are elastic, they are always in a straight line motion, the kinetic energy is dependent on the temperature.
Can't really use P equals to NRT for anything.
See, most of the situation, the reaction, the questions which you're going to out there, you're going to use that. But we are going to modify that PV is equal to nRT by introducing the molecular interaction and the volume changes both into the equation to get a real gas situation. Okay, that is what we are going to do in the next class. But as of now, I want to ensure that the kinetic theory of molecules is clear to you guys. Stating that this graph is important, I will tell you what type of question. So similarly, I'll get certain question based on what type of questions are generally asked in this. And what is the formula for UM? So for your homework, so that you open up. Formula for velocity of most probable, formula for velocity of average, and formula for velocity of RMS. It's given in your textbook. And what is the relationship between the three of them? What is the ratio? You need to just find out and tell me tomorrow. I think tomorrow we are meeting up again. I think so. I'm not sure. Maybe tomorrow or day after, whenever we are meeting. So you are going to bring me and gather these two particular equations so that you open up the book and revise it. Karan, is it clear?
Yes, ma'am.
Can you do that for me?
Yes, ma'am.
What have I asked?
Ma'am, velocity most probable or average probable?
Average and RMS. इन तीनों का फॉर्मूला क्या है और इन तीनों के बीच में रिलेशनशिप क्या है और क्या रेशियो है इन तीनों के बीच. क्लियर? कर दोगे?
Yes, ma'am.
Fine. So we'll stop here for today, and I shall see you in the next class. Okay? Any doubt? Please practice question.